So we want to do a bit more of like a high-level technical overview, not technical, just high-level overview of what's the state of generative media in 2025. So just kind of high-level, where are things, what tools should we use, where have things been going on? So it's kind of like, we've all seen these fun VC charts, right? They love to box different tools, and these tools raise hundreds of millions of dollars, but kind of what are they doing? What are the players? What's kind of going on under the hood? So application level, what's like below that? What's kind of been going on? So what are the different modalities of generative media? There's kind of four that come to play, right? We've got LLMs, we've got image generation, video, and voice. So the very, very easy kickoff is kind of LLMs. This is kind of my background. So I used to do foundation model research on LLMs. Very, very simple, but what goes on under the hood, basically you just predict the next word. That's kind of how we've got to models like we have today. So love these fancy charts, you know? We had GPT-3, ChatGPT, Claude, Gemini, Microsoft 5 models, Mistral, all that stuff. But what's going on under the hood? A kind of timeline over the past 5 years is we used to have like these encoder, decoder models. They start, well, first we even had like RNNs. From there we had Google released stuff like BERT, which was, you know, let's use the attention mechanism. Let's make something for like translation. From there, we found decoder-only models. This is kind of where stuff started to kick off, right? We had GPT-2. From there, everything is kind of built on decoder-only models. We had Llama, Claude, OpenAI, all that stuff. Then from there, we started taking these autocomplete models like Karan was talking about, where all we were doing was just predicting the next token. We started to turn them into chat models, right? So that's where ChatGPT came out. So GPT 3.5 or Llama 3. We started to turn them from fancy autocomplete engines to chat models. We did this with stuff like SFT, RLHF, and these are kind of the buzzwords and where they fit into the timeline. After that, we found out there's this whole MOE term where we can make models effective, more efficient to serve. That's called mixture of experts. Then we really started scaling up. So Llama was trained on 15 trillions of tokens, right? Basically training on the whole internet. And now we have all this fancy GRPO used in DeepSeek, but high level, we kind of just started predicting the next token, training on a bunch of tokens, and then we have this post-training phase of reinforcement learning to make them chat models. And that really worked. People really like chatting with these models. So Character AI, ChatGPT, they've got over 100 million daily active users, and things are blowing up. And you know, we've kind of got this chart, but that's kind of what everyone understands. Everyone kind of knows how LLMs work under the hood. There's token prediction, there's RL, and there's attention. But let's kind of take a layer back at some of these other modalities. So what's kind of going on in image generation? Early on, we kind of had GANs, if you've heard, the generative adversarial networks. They were cool. They kind of started doing some of that early 2020 image generation stuff, but eventually Stable Diffusion sort of took over. So we've all heard of Stability AI and you know these image generation companies that can generate super high resolution, realistic images. We've used stuff like DALL-E, SDXL, all those things. Well, they kind of took a similar approach to text generation and they rephrased the problem. So instead of labeling images and just like trying to generate them, what's happening under the hood is we start with an image of random noise and we train steps to iteratively predict and like convert that noise and denoise it into an image. So what you're doing is basically you can take images, you start to make them noisy. So, you know, you add random filters, you sort of mess with the image, you augment it, and now you've got training data. And you kind of work backwards. You just start at a step of noise, and you start to predict back to the main image. We scale it on all the images in the world, and we've kind of got stable diffusion. And that started to really take over. The middle steps was, you know, there were clip models, which were really good captioners. Clip and text to image models started having us generate images. Stuff started to become open source, so Stable Diffusion came out, ControlNet, TemporalNet. These were kind of the next advances. So Stable Diffusion is great to generate one image. ControlNet, TemporalNet are kind of when we want consistency, we want to edit that image, we want to kind of mask over layers, do imprinting, and all that has kind of led to today where now we have tools like Kriya AI where you can really have a really good workflow, you know? You generate an image, you change parts of it, you imprint it, you iterate over it. And that's all still kind of based on that original stable diffusion, which is you take noise and you just work backwards to generate an image. And people love it. Mid-Journey Discord is kind of the most traffic that Discord gets. Stable diffusion community is huge. Traditional companies have started taking over. So Adobe released Firefly. And with this, there's obviously a bunch of like litigation, lawsuits, Shutterstock images coming in. But at a high level, we kind of took the same phrase of predicting the next token and started just generating images from noise. And that's kind of stable diffusion. Key timelines in this. So in 2022 is where we had DALL-E 2, OpenAI's image generator launch. We had Mid-Journey launch, and we kind of had stable diffusion come out. 2023 is when we had stuff like ControlNet and AI editing, make it possible so that we can take simple images, add like, you know, consistency, generate more images in the same style, start to generate extrapolated video, keep that consistent. 2024 last year is when we started to see this stuff get really good, right? So SDXL was bigger stable diffusion, open source, so you can run it on your own computer. That was a huge phase, right? Everyone can now locally run their own really good image models. DALL-E 3 came out from OpenAI. That was like, you know, it's got the mover's advantage, right? Everyone already uses OpenAI and now they can all generate images. 2025, Mid-Journey V7 has come out. Mid-Journey recently said they might do video. Adobe Firefly 3, the big company, is still working on it. So image generation is kind of, you know, it's very mature now. What about this other modality of video generation? Video generation is kind of where we're like sitting right now, right? When we very early started on, we started to see like frame by frame generation where we would just stitch together a bunch of images and now you kind of have a video. And turns out that that's actually what's going on behind Sora. So Sora was kind of that major point last year where we saw, whoa, you can take like a big step up in video generation. We saw some very impressive long form video generation. So the OpenAI team released a pretty comprehensive blog post behind Sora, and they kind of explain what they're doing. What they're basically doing is they take the problem of diffusion, and they say that video is just images stitched together, right? So like the cameras recording here are recording at a certain resolution, 1080p, 30 FPS. So that's kind of 30 frames per second of images. So they're like, if you extrapolate that out to video, you just have images stitched together. They kind of rephrased the training problem, and now they mapped it as a diffusion problem. So now we've got diffusion stitched together at scale, and boom, you can generate videos. In the interim, there was little stuff that started to fix the kind of hacky diffusion stitched together. There were things like temporal net. Temporal net was when you have 2 or 3 images stitched. Can we kind of predict the middle frame and kind of have better consistency between these jumps? From there, kind of the big companies start to take over, right? So Google launched VO2, VO1, VO2. Those are kind of Sora competitors. Sora actually came out, bit of a disappointment, but you know, they're working on making it better. Runway launched, Pika launched. And then we started to see like, this was more of a slower rollout, right? ChatGPT just launched overnight. Mid-Journey, all these companies, they just kind of launched overnight and we had access. OpenAI kind of took here's a preview, here's the state of the art, here's like Hollywood studios with professional sound editing, using these tools and showing us what they're capable of, and they're still launching. But once again, timelines are fun, you know? So 2022, Meta started to do stuff, Google started to do stuff. They had like, Meta had make a video, Google had image gen video. They were kind of like the first showcase of, this is not great, but like, whoa, video from big company. 2023 is when we start to see Runway and Pika companies that were like, okay, we can take what's out, build on it, be that first mover, and like have people actually start to use it. So Runway Gen 2 launched, Pika launched. Last year we had stuff like Sora, bigger companies, Instagram, TikTok, they started using it. Genmo launched a big open source model last year, end of last year. So now we even have open source Sora level generation. They just came out. I think they're speaking later today. And then this year, we're obviously still working on it. So Google launched VO2, which is kind of better than Sora in some levels. It's out, it's cheap, and like people are starting to use these things. Yeah, and then our last modality is kind of audio generation, right? Audio generation is a fun one because this started to come in pretty early. audio generation isn't as extensive, right? We're not generating thousands of images. It's not as heavy to do. So as early as like 20 years ago, we started to see these deepfakes emerge, right? You could basically take audio, like the voice I'm speaking now, look at a spectrogram and throw it in any model. So like RNNs were used for this, CNNs were used for this, and you could just kind of start to transcribe these things and they would work. And there were open source initiatives around this. But from there, there's kind of a few key inflection points in the past 10 years that, like, Whisper came out, text-to-speech started to come out, voice cloning started to come out, and now this stuff has started to really ramp up. So 2016, we kind of had a kickoff of like, here's things starting. Whisper in 2022 was OpenAI's open source transcription service. That's when we started to have this shift of, instead of like just generating from spectrogram, let's start to convert this to token-based generation, right? So we can tokenize audio, we can do token-based decryption. People tried stuff like diffusion for audio. We tried adding attention to audio. There were a lot of cool little things. So Jukebox was here, Music LM, a lot of different things. People tried VAEs. There was just a lot of like research going on to make this stuff really, really efficient. Now we have companies like Cartesia, Deepgram, 11 Labs that have kind of really commoditized it, right? We start to see stuff like voice cloning. So 11 Labs, you can clone stuff in just a couple seconds. OpenAI started to reach it. And that's kind of where we're at today, right? So we've gone from just separate transcription models to generation models to let's actually integrate this in with the LLM. So OpenAI's advanced voice mode is sort of let's natively train models that are text and audio. And now we have like really good LLM understanding plus audio. More timelines. So Audio LM was from Google, Music LM in 2022. They were starting to do this. Of course, we did see in 2024 the actual music companies, right? So I don't know if we've heard of Udio or Suno AI. They kind of have like end-to-end music generation. 2023 is when we start to see the big API providers make this really accessible, right? So 11 Labs launched. I'm sure everyone here has heard of 11 Labs. You can kind of just, in a couple cents, call an API, and you've now got instant voice generation. And then now, as we're starting to see it in 2025, we have native models that are starting to like combine the LLM intelligence with this. So quick wrapping it up, what can we kind of expect in the future, right? So we've seen a lot about agents. What happens when agents start to use these autonomous generative tools, right? So when agents can do generative video, audio, all that stuff, where is the world gonna go when we can like efficiently generate 30-minute videos in 2 seconds, right? Do we just flood the internet with garbage? These are all questions to think about, right? What happens when this stuff is like all very seamless? It's just one chat model, you get everything you want, it's done right away. I don't think we're too far away from there, but it's stuff to think about. And there are questions to think about with this too, right? So if you're working on the research end, right? How can we make this more efficient from a compute standpoint? How can we really scale down? How can we quantize? How can we make it more efficient to do this large-scale generation? Because it's not optimized now. From an ethical copyright standpoint, I believe we have a panel on this later and a speaker that's going to speak about the licensing stuff. Some companies are pretty forward-thinking, right? So the chain smokers, they've got an investment fund in this. Companies like Sony, Universal, Warner, they've done lawsuits over this. What about the UX? What about regulation and policy? All this stuff we'll hear from other speakers. But yeah, I want to pass it on. Thanks for my yap listening.
Thank you, Vibhu. Really appreciate it. Next, we're gonna start our multimodality session today. And I want to invite our first speaker, Richard from Adobe. Adobe has been working on Firefly for a while, and I think Richard has been given one of my favorite topics on data attribution, which is really critical to a lot of multimodality model developer. How to think about trustworthy to trace my data provenance.